Hi guys, today what we're going to be looking at is rationalising the denominator. So we're going to learn to understand that a third multiplied by itself gives a whole number, to know that rationalising the denominator refers to converting an irrational denominator to one that is rational, and to be able to rationalise the denominator of a fraction. You'll feel successful today if you can rationalise a denominator. So it is easier to work with thirds when they express using a whole rational number in the denominator. The process that removes the third from the denominator is called rationalising the denominator. Because the denominator is being converted from an irrational number to a rational number. Rationalising the denominator involves multiplying by the irrational number. So if we have x divided by root y, what we need to do is we need to multiply both the top and the bottom of the fraction by root y. This results in x times root y, which is x root y, over root y times root y, which just equals y. Okay, let's have a look at our examples. So if we have 2 over root 3, what we need to do is multiply the top and the bottom by that denominator of root 3. When we do this, we'll have 2 times root 3 is just 2 root 3, divided by root 3 times root 3 is 3. Let's have a little look at C. So C is 3 root 2, all divided by root 5. So what we need to do is multiply both the top and the bottom by that irrational number of root 5. And when we do so, we are left with 3 times root 2 times root 5, which is just 3 root 10, all divided by 5. This gets us our final answer of 3 root 10 on 5. Please copy down A and C and have a go at BD. Okay, so if you haven't already had a go at BD, please make sure you pause the video. So for 3 over root 2, we need to multiply the top by root 2 and the bottom by root 2 to eliminate that irrational number on our denominator. This gets us with 3 times root 2, which is 3 root 2, over root 2 times root 2 is just 2. For D, what we're going to do is we have 4 root 3, all divided by root 7. So we're going to multiply the top by root 7 and the denominator by root 7. So 4 root 3 times root 7 is 4 root 21, all divided by 7. Moving on to E, we have 2 root 5 all divided by 5 root 2. Now we only want to multiply by that irrational denominator here, and that irrational part of our denominator is the root 2. So we only multiply both the top and the bottom by root 2, resulting in 2 root 7 times root 2 is 2 root 14 over 5 lots of root 2 times root 2 is just 2. This gives us an answer of 2 root 14 on 10, and we can simplify our fraction of 2 on 10 to be root 14 over 5 because 2 and 10 are both divisible by 2. Finally, for G, what we have is we have 1 minus root 3 divided by root 3. So we're going to multiply by that irrational number on the denominator of root 3 to the top and the bottom. So what we get is 1 times root 3 is root 3, minus root 3 times root 3 is positive 3, all over root 3 times root 3 is just 3. Pause the video and have a go at F and H. Okay, looking at F, we wanted to multiply by that irrational number on our denominator where we have 2 root 5 divided by 3 root 2. So we're going to multiply the top by root 2 and the bottom by root 2. So 2 root 5 times root 2 is 2 root 10, all over 3 lots of root 2 times root 2, which is just 2. This gives us our answer of 2 root 10 all over 6, and we can divide both the 2 and the 6 by 2 to get root 10 all over 3. Finally, for h, we need to multiply the top by root 7 and the denominator by root 7 to eliminate that root 7 on the denominator. This gets us 2 times root 7 is 2 root 7, minus root 7 times root 7 is just 7, all over root 7 times root 7, which is 7. Now, what we can have is rationalizing a binomial denominator. So when there is a binomial denominator, we use the difference of two squares to rationalize the denominator. This involves multiplying the fraction by the conjugate of the denominator. So what the conjugate means, it means by multiplying it by the same surds, or the same thing on the bottom, but what we have to do is change the sign between the two terms from a positive to a negative, or a negative to a positive. So what we have for A, what we have is if we have B over root C plus root D, we need to multiply by root C minus root D on both the top and the bottom. So what's happened is that plus has changed to a minus. Or if we have B over root C minus root D, what we do is we multiply both the top and the bottom by root C plus root D, meaning that we've changed that minus to a plus. So for our first example, we have 2 divided by root 2 plus 1. So our conjugate is root 2 minus 1 that we need to multiply to the top and the bottom. So what we have is we have 2 outside of root 2 minus 1 on our top, and on our bottom we have a perfect square. The difference of 2 squares, sorry. So what that means is we square our first term minus the square of our second term. So we have root 2 all squared minus 1 all squared on our denominator. If we expand our numerator, we'll have 2 root 2 minus 2 all over our denominator of root 2 squared is just 2 minus 1 squared is just 1. So our denominator stays the same as 2 root 2 minus 2, and our numerator stays the same as 2 root 2 minus 2, but our denominator is 2 minus 1, which is just over 1, so we don't need to write it over 1. Now, I've made a mistake with B. It's 4 over the square root of 3 plus 1. So pause the video and have a go at that for me, please. Okay, hopefully you multiplied the top and the bottom by root 3 minus 1. So when we do that, we get 4 lots of root 3 minus 1 all over. Now we square our root 3 and we minus, and then we square our second term of 1 there. Expanding our numerator, we get 4 root 3 minus 4 all over 3 minus 1. This then gets us the answer of 4 root 3 minus 4 all over 2. And what we can actually do is we can simplify this. So you probably didn't simplify, but what we can do is simplify by factorising out a 2 on the top. So 4 root 3 divided by 2, we're left with 2 root 3 minus 2 all over 2, and so that 2 on the top cancels out with that 2 on the bottom, leaving us our final answer of 2 root 3 minus 2. Okay, moving back along to C. For C, we want to multiply the top and the bottom by the conjugate of our denominator, so we're going to multiply by 1 plus root 2. This gets us 4 lots of 1 plus root 2 all over 1 squared minus root 2 squared. So that's 4 plus 4 root 2 all over 1 minus 2, which is 4 plus 4 root 2 all over negative 1. And we can just bring that negative up the top out the front. Okay, so we get negative lots of 4 plus 4 root 2, which if we multiply the negative in, it's negative 4 minus 4 root 2. pause the video and have a go at D. Okay, for D, you should have multiplied by 6 plus root 7 to the top and the bottom, leaving us with, I'll just do it down here, 7 lots of 6 plus root 7, all over 6 squared minus root 7 squared. So 7 times 6 is 42, plus 7 root 7, all over 36 minus 7. So this leaves us with 42 plus 7 root 7, all over 36 minus 7 is 29. And that's our final answer there. Good luck and have a go at exercise 4D for me, please.